In this lesson, we are going to condense logs. Typically, we condense logs to help us solve equations. So we're going to be using these properties, but we're going to be going kind of backwards from what we previously would have done. So we have stuff like this where you have numbers in front of your logs. Those numbers will pull back as exponents. If you have addition, then these two logs are going to condense into two pieces multiplied together. If you have subtraction, then these two pieces are going to condense into one log with two pieces dividing into each other. So that is our goal. So on this one, we have that 3 is not in the front, so it's already been pulled back. We have addition between the two. As long as the bases match, we're going to take two logs and put them together into one multiplied piece. So it's p to the third times q. And that's it. On this thing, we have two logs, and they are going to pull together because of the subtraction into a division problem. So it's 64 over 16. That might be okay, but it might need to be simplified because 64 minus 16 actually is 4. All right. This thing, as long as the logs match, so the natural log matches the natural log, you have a subtraction, which means you have a division. Here's the first divided by the second. All right, and of course, can't be that easy because this factors. So that quadratic factors into, you need things that are going to multiply to 3x squared, so it's going to be a 3x and an x. You need these two pieces to multiply to 2. So either I'm putting the 2 across from the 3, so I distribute it and get a 6, and then this would be a 1, which can make 5, or I'm putting the 2 here, and then that 2x and that 3x, like a 2 and a 1, are going to make 5. Well, this tells me the signs need to be different. So I'm going to go this route because this is a 6x, and this is a 1x. Now I get that a 2x and a 3x make 5, but they are going to be different signs and add up to a positive. So that's going to be a positive 6 and a negative 1. So that's going to give me my 5x. So not at all a coincidence that that cancels that. So really your answer ends up being the natural log of 1 over x plus 2. Tricky. All right, and then the last of the condensing is we have 1, 2, 3 pieces, so we're going to condense them all together. That 5 is going to become an exponent. The 1/4 is going to become an exponent. And then the fact that you're subtracting means you're going to have a division piece. So I'll show you two different routes to go on this thing. So the first thing we can do is if we kind of just do the properties as is, we'd have x to the 5th minus log base b of y plus log base b of z to the 1/4. And then you can condense it. So you're pulling 3 logs into one piece. So we're going to have 3 pieces all put together here. And the only one that's being subtracted is the y, so that's going to be the one in the denominator. And these are both positive, so they're going to be up in the numerator. All right, and that's it. Now, the different approach to this is, once I get here, I actually could treat this like a negative 1. So I could have rewritten this as log base b x to the 5th plus a log base b y and make that a negative 1 exponent. And then plus log base b of z to the 1/4. So if I do that and I get rid of this and I make everything positive, That means everything that I have here, I can just put as them all just multiplied together. And then at the very end, oh, negative exponent. Let's simplify that. So it's just an option. So my positive exponents I would leave alone. And then my negative exponent I would bring it down. If you want to put a 1 on it, you can, but you don't have to. So just two different approaches to it. If you're getting thrown off by positives, negatives, or whatever, then just pull everything and treat everything like an exponent. So pull the 5 back, pull the negative 1 back, and pull the 1/4. And that way you can treat it all as in one just big multiplication piece, and then you can deal with your negative exponent second. So just an option. If you're okay with the fact that the subtraction means it's a division problem, then great. Otherwise, here's just another option if it helps. And that was condensing logs.